Everyone, welcome to my mathematics class, standard 5, chapter 6, which deals with HCF and LCM. In previous class, means in standard 4, you studied about multiples, factors, even numbers, odd numbers, prime numbers, composite numbers. So let us have a quick review of what we have studied or what we have learned in standard 4. And exercise 6a, your exercise 6a is based upon multiples, factors, even numbers, odd numbers, prime numbers, composite numbers that you studied in standard 4. So I hope you can solve these problems of exercise 6a. So today I am going to discuss about this chapter. We started from prime numbers. So what are prime numbers? The numbers which cannot be broken into factors other than 1 and itself are known as prime numbers. The examples 2, 3, 5, 7, 11, 13, etc. and etc. Again you see the prime numbers are those numbers which have only two factors, that is 1 and the number itself. The number having only two factors are known as prime numbers. For example, these are the examples 2, 3, 5, 7, 11 and 13. But you notice an interesting fact here is that 2 is an even number and it is also a prime number. Except 2, there is no such even prime numbers. 2 is the only even number which is a prime number. Other even numbers are not prime numbers, they are composite numbers. Only 2 is the exception. Now composite number, numbers which can be expressed as product of factors other than 1 and itself are known as composite number. For example 4, 6, 8, 9, 10, 12, 14 and 15. The numbers which have more than two factors are known as composite number. Composite numbers are not only even, the collection of composite numbers is a mixture of even and odd numbers both. 4, 6, 8, 10, these are the even composite numbers. 9, 15, 21 and so on are odd composite numbers. Since we cannot express 1 as product of two different factors other than 1 and itself, so we say that 1 is the only exceptional number which is neither prime nor composite. 1 is a number which is neither composite nor prime. To determine whether a particular number is prime or composite, we don't have a set of formula. For this, we have to perform actual division so many times in order to check it. A Greek mathematician, Eratosthenes, developed a method in 3rd century BC to find prime numbers. His method for finding prime numbers is very popularly known as sieve method. For numbers from 1 to 100, this method is explained below. You see. First, write all the numbers from 1 to 100. Then cross out number 1 because number 1 is neither prime nor composite. Now, next number is 2. It is the first prime number. We keep it and cross out all the multiples of 2. Now keep it out and cross out the multiples of 2. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 88, 86, 88, 90, 92, 94, 96, 98, 100. These are the multiples of 2. Now, next number is 3. It is the next prime number. We keep it and cross out all the multiples of 3. The multiples of 3 are 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, etc. Now next uncrossed number is 5, that is the prime number, and keep it and cross out all the possible multiples of 5. That is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. Now, the next uncrossed number is, you see, this is the crossed number, and next uncrossed number is 7. Now, keep it and cross out all the multiples of 7. 7 multiples of 7 are 14, 21, 28, 35, 42, 49, 60, 63, 70, and so on. Continue keeping the next prime numbers and crossing out their multiples until we left with prime numbers only. After crossing out, the uncrossed number are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So there are 25 such prime numbers from 1 to 100. Now, twin prime numbers. Two prime numbers which differ by 2 are called twin primes. For example, 3, 5, 5, 7, 11, 13, 17, 19. Such numbers will form a pair of consecutive odd numbers. Now, prime triplet. A set of 3 prime numbers differing by 2 from a prime triplet. 3, 5, 7. The difference between 5 and 3 is 2. 7 and 5 is also 2. So the 3, 5 and 7, these 3 are the prime numbers, and they are differ by 2 from each other. So 3, 5, 7, this is a prime triplet. 3, 5, 7, this is a prime triplet. 3, 5, 7 is the only prime triplet. There is only one prime triplet, that is 3, 5, and 7. Now co-prime numbers. A pair of two numbers which have no common factors other than 1 are called co-prime numbers. 2, 3, 3, 4, 4, 5, 3, 7, 4, 9. Co-prime numbers need not be prime numbers themselves. For example, 4 and 9. 4 is an even number, 9 is a odd number. And 4 and 9, these two are also composite number, you see. But 4 and 9 are said to be co-prime number because they have no common factor other than 1. The only condition for two numbers to be co-prime is that there is not even a single number other than 1 which divide both of them. So this is exercise 6b. It is based upon these facts: a prime number, composite number. Now we discuss about divisibility rule. Divisibility rule help us to find whether a number divides another number completely without performing an actual division. Divisibility by 2. A number is divisible by 2 if it has 0, 2, 4, 6, and 8 at its ones place or units place. For example, you see here that is 240. Its unit place digit is 0, so it is divisible by 2. In 1752, the unit place digit is 2, so it is divisible by 2. In 2014, the unit place digit is 4, so it is also divisible by 2. 85,396, unit place digit is 6, it is also divisible by 2. 53,178, its unit place digit is 8, it is also divisible by 2. So the number is divisible by 2 if its unit place digit is either 0, 2, 4, 6 or 8. If the number contains either 0 or 2 or 4 or 6 or 8 at its unit place, unit place, then the number can be divisible by 2. Now divisibility by 3. A number is divisible by 3 if the sum of its digit is divisible by 3. For example, again, a number is divisible by 3 if the sum of its digit is divisible by 3. For example, 4518. Now sum of the digit is 4 plus 5 plus 1 plus 8 is equal to 18. So 18 is divisible by 3. The sum of the digit is 18 and 18 is divisible by 3. Hence the number 4518 is also divisible by 3. Consider another number 72,019. Now take the sum of the digits. 7 plus 2 plus 0 plus 1 plus 9 is equal to 19. 19 is not divisible by 3. So the number 72,019 cannot be divided by 3. Divisibility by 4. A number is divisible by 4 if the number formed by its digit in tens and ones place is divisible by 4. A number is divisible by 4 if the number formed by its digits in tens and ones place is divisible by 4. For example, 7,80,456. You see, ones place digit is 6 and tens place digit is 5. So the number formed by ones and tens place digit is 56. Now divide 56 by 4. Now on dividing, 56 is divisible by 4. So the number 7,80,456 is also divisible by 4. Another number 7,52,963. Now the digits of unit place is 3 and digit of tens place is 6. Now the number formed by the unit place and tens place digit is 63. Now divide 63 by 4. You see that 63 cannot be divided by 4. So the number 7,52,963 is not divisible by 4. Divisibility by 5. A number is divisible by 5 if it has 0 or 5 at its ones place. A number is divisible by 5 if it contains either 0 or 5 at its ones place. Then the number is divisible by 5. For example, 8,975. Its units digit is 5. So the number 8,975 is divisible by 5. Another number 75,293. Its unit digit is 3, which is not divisible by 5. So the number is not divisible by 3. Divisibility by 6. 6 is a multiple of 2 and 3. We know very well. So we write the multiples of 2, 3 and 6. We have multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 24. And 3 are 3, 6, 9, 12, 18. So the common multiples of 6 are 6, 12, 18 and 24. We find that 6, 12, 18, 24 come in both the list of the multiple of 2 and multiple of 3. So we can see that if a number is divisible by two co-prime numbers, it is divisible by their product also. Therefore, a number which are multiples of 6 are multiples of both 2 and 3. Thus, a number is divisible by 6 if it is divisible by 2 and 3 both. If the number is divisible by both 2 and 3, then the number is divisible by 6. Divisibility by 8. A number is divisible by 8 if the number formed by its digits in the hundreds, tens and ones place is divisible by 8. For example, 72,15,976. The unit and 10 and 100 place digits are 6, 7 and 9 respectively. The number formed by their units plus, tens plus and 100 plus digits is 976. 976 is divisible by 8. So the number 72,15,976 is also divisible by 8. Divisibility by 9. A number is divisible by 9 if the sum of its digit is divisible by 9. Like the divisibility of 3. For example, a number is given that is 90,981. Now the sum of the digit is 9 plus 0 plus 9 plus 8 plus 1, that is 27. 27 is divisible by 9. So 54. So 90,981 is divisible by 9. Another number 54,731 is equal to 5 plus 4 plus 7 plus 3 plus 1 is equal to 20. So 20 is not divisible by 9. So 54,731 is not divisible by 9. Divisibility by 10. A number is divisible by 10 if it has 0 at its ones place. Remember, a number is divisible by 10 if it has 0 at its ones place. For example, 98,370 is divisible by 10 because its unit digit is 0. 53,948 is not divisible by 10 because its unit digit is 8. Now divisibility by 11. A number is divisible by 11 if the difference of the sum of the digits in odd places and the sum of its digit in even places starting from units place is either 0 or divisible by 11. Consider the following number: 4,961. So sum of the digit in odd places are 1 and 9. So 1 plus 9 is equal to 10. Now sum of the digit in even places 6 and 4. 6 plus 4 is 10. Now difference of the two sums, 10 minus 10, 0. Hence 4,981 is divisible by 11. So now exercise 4C. Exercise 4C is based upon divisibility test and multiplication factors. I have tried my best to make you understand this concept. In the next video lecture, we will discuss about multiplication factors. Thank you for watching my video.